Hey folks, so this is going to be the last video that we're doing in section 1.7. If you'll go all the way down to where we talk about rational inequalities. All right, so for this particular example number 8, what we're going to do is we want to know where is this fraction greater than or equal to the number 4. And we're going to use the calculator to do this. So I have the calculator open already. And so in y1, if you'll go ahead and type in 6 divided by, now you need to make sure that you understand this next part. When you are dividing by a whole entire quantity, that must go in a set of parentheses. So you're not just doing 6 divided by x, you're doing 6 divided by an entire quantity of x minus 3. Go into y2 and go ahead and type in y2, y2 equals 4. And what we're going to look at is we're going to look at where does this side intercept this side. Now, I'm going to have to switch my window a little bit. I had a large window from the last video. So I'm going to go back and do -10 to 10, just a standard window. And we'll see what the standard window looks like, and then I'll see if I need to adjust that. So go ahead from the standard window and you can graph. Now, I've got mine at a slightly stretched out, or however you want to say it. Mine's a little bit different dimensions, but that's okay. You can get the idea. All right, now we're going to learn a whole lot more about graphing rationals later in the semester. For now, let's just look at a couple of things. We know that we cannot equal an x value cannot be 3 because that would make a 0 on bottom. So you'll notice that on the calculator, let me swing over here. On the calculator, I've got this vertical line, and that's through x equals 3. Your calculator may or may not show that, but this is for free, we'll learn it later. This is called an asymptote, a vertical asymptote, and this is like no man's land. You cannot touch a vertical asymptote. So you see that on our calculator, and then you also see this curved piece on the right side of that x equals 3, and another curved piece on the left side of x equals 3. All right, and then also in on the calculator, it's a red line. On my graph here, it's a green line through y equals 4. And what we want to know is where is this part of the graph? So this is my curved part of the graph. Where is that above or on? All right, so that's key here. We want to know above or on that line y equals 4. Well, we see here on our graph that anything above or on y equals 4 is going to be this part as well. And really the only part of my graph that's above or on the 4 is just this part right here. So what we need to do is we need to find out what this intersection is. Once we find out what this intersection is, we'll be able to say what this piece is. So go back to your calculator, and what we'll do is we'll go back to second trace. Once again, we want to go to number 5. Now, on the last video, I walked you through how mine looks different than yours does. Mine is asking for a left bound. Yours will be asking for first curve. Before I do anything, before I answer my question, or before you answer your question, your cursor needs to be blinking close to this intersection. So I gotta get here. There's a lot of tapping involved. Sorry about that. Gonna get close to my intersection. And I am going to get very close to that intersection. Okay, so then you can see that my cursor, I'll show it to you on the iPad, my cursor is close to right around in here. All right, and so once you've got your first curve, and you probably only have 2 curves in there, so once you have your first curve, push enter. And mine's asking for right bound. Yours is going to ask for for second curve. You don't have to move your cursor anywhere. I do. And then it'll ask you to guess, and you don't want to guess. And what we notice is that these two are going to intersect each other at the value of x equals 4.5. X equals 4.5. Okay, and if I can unhide what I've got here, I said that the intersection occurs, I used a coordinate where the x value is 4.5 and the y value is 4. Okay, now we want to know then what are all the places on my graph that are going to be above this line. We already know it's this piece. Well, where does this piece begin? This piece doesn't begin, it doesn't begin back here. This piece doesn't begin until right after this x equals 3 line. So our above part, above or our on part, starts at x equals 3. But remember, you cannot touch a vertical asymptote, so that's why I used a round parentheses on the 3. And then I'm going to still be above or on that y equals 4 line all the way up until the x value of 4.5. And since this is on or above, I use the square bracket for that reason. All right, then let's go to example number 9. So I will go to my calculator. Let's clear out what we have in the calculator. And in Y1, we will type in our fraction. Again, make sure that you use parentheses around the whole top and parentheses around the whole bottom. So I have an x plus 4 in a quantity divided by, use your division symbol for your fraction bar, divided by the quantity x plus 7. And I'll go ahead and keep the standard window that I already had. And you can see here what we're looking at. Now, the window is not phenomenal. If you want to go back and change your x minimum to maybe something like -20, that will show you a little bit more of your graph. And there's a couple things that that we will learn later on, but we already know that the bottom cannot, the x cannot equal -7 because that would make the bottom 0. So you notice that I have this vertical asymptote here at x equals -7. For free, again, you'll learn this later, we do have what's called a horizontal asymptote through y equals -1, but for this particular question, that's not going to make that much of a difference. We want to know where is the graph above the x-axis. Why the x-axis? Because the x-axis is where y equals 0. So here's our y equals 0 line. We want to know what parts of our graph are above the x-axis. So if I'm using my highlighter, that means that we're going to have everything above the x-axis. Okay? So as I'm looking at this, it looks like I have 2 pieces that are above the x-axis. This is above the x-axis, and this is above the x-axis. All right, now this one's easy. So we have x equals -infinity is where this guy starts. So x equals -infinity all the way up to x equals -7. All of that is going to be above the x-axis. Now I'm going to end up unhiding more than I want to, so forgive me, spoiler alert, you're going to see more than you want. So -infinity to -7 is going to be that first piece. Now for this piece, my, sorry about that, my intercept, okay, it's messing with me here. My intercept is at x equals -4. There's a couple ways you can find that over on your calculator. If you go to second trace, you can use option number 2 for 0, and it's asking you for left bound. So let me get to the left of that x-intercept. This is looking exactly like yours. Once you're there, you can push enter and then arrow to the right of that x-intercept. And then your calculator will ask you if you want to guess, and you can just push enter. You don't want to guess. But you can see there that my 0, my x-intercept, is at x equals -4. And so from the x value of -4 all the way to +infinity, then that is also above. Now, If this question had not had just a greater than, where it's only above, what if it had been a greater than or equal to? What would that have looked like? Well, this piece would have been identical. It's this piece that would have been a little bit different because this is the only part that is on. And so if that had been a greater than or equal to, the only difference would have been a square bracket here on that -4 to ensure that that was on the x-axis. All right, that's it for this particular video.